In our next section, we're going to talk about the zone-based policy firewall's performance tuning that, similar to CBAC, is used to control the individual parameters of the TCP, UDP, and ICMP sessions, and control options like the prevention of TCP denial of service attacks. Now, just like CBAC, zone-based policy firewall supports the tuning of the individual TCP session options, things like what are the limits on the incomplete sessions, which again are also known as the half-open sessions, or what the ASA calls the embryonic connections. This would be used to prevent any type of TCP SYN attack, where the attacker sends the first portion of the TCP three-way handshake to the server replies with the SYN and the ACK, and then the attacker doesn't fully open the session by replying back with the final acknowledgement. Additionally, we can control the SYN parameters, like how long is the firewall going to wait once it receives the initial portion of the three-way handshake for the server to actually reply. The FIN timers, which would control how long do we actually manage a session after it's complete, and different idle timers and miscellaneous parameters of the individual TCP sessions. Now, for UDP and ICMP sessions, since these are not connection-oriented, we'll see that there's many fewer options that we can control. Mainly, UDP and ICMP sessions are just going to be controlled by the idle timeouts. So once I hear an ICMP echo, how long am I going to wait for that ICMP echo reply to come back in before the connection is removed from the state table? Now, differently from the content-based access control, where these parameters were directly defined with the ipinspect command, in the zone-based policy firewall, these are going to be defined with a parameter map. Now, the parameter map is going to define the TCP intercept settings and other generic content-based access control settings, because remember, even though the zone-based policy firewall is a different syntax interface for the firewall feature set, it's still using the same CBAC inspection behind the scenes. So in order to change these type of parameters, we're going to define a parameter map that, like the previous class maps and policy maps that we saw, are going to be of type inspect. And this is where we would change options like what are the maximum incomplete TCP sessions, what's the TCP SYN wait time, what's the TCP FIN wait time, etc. We also have an option here to turn on alerting, which is going to generate log messages based on the parameters that we define, and the audit trail that is going to show us a verbose log of the actual TCP connection that is occurring from the client to the server. Now, once we actually define the parameter map, it's going to be applied on the inspect action inside of the class, inside of the policy map. So recall, the first thing that we're going to do with the zone-based policy firewall is to classify the traffic with the class map type inspect. This is where we would say match protocol HTTP, match protocol ICMP, etc. Once we define the class, then we are going to define our policy map type inspect. Inside the policy, we are going to reference the class. Then we're going to choose our action. So are we going to inspect the traffic? Are we going to drop it? Are we going to pass it? In this case, for the parameter modifications, we're going to use the inspect command followed by the particular parameter map's name. Now, in the current topology that I'm using, router 3 is going to be running the zone-based policy firewall, where the connection to the frame relay network is the outside, and the inside LAN interface connecting to router 4 is going to be the inside. So we're going to look at modifying the parameters as traffic goes from the inside to the outside and then returns, and as traffic tries to move from the outside to the inside. Now, for the next few examples, the way that we're going to do this is to configure router 4 as a web server, and it's also going to be configured as a DNS server. So for devices on the outside of the network, router 1, for example, the test PC, when their sessions are coming in from the outside, going inside, we're going to allow the web traffic, we're going to allow the DNS traffic, and then also for some basic verification, I have it configured to allow ICMP traffic. So next, let's look at the currently configured policy on router 3. Again, for verification of the zone-based policy firewall, we would look at things like the show zone security. It says I have 3 zones. One of them is inside, one of them is outside, where again, these are my user-defined zones. And then we have the self zone that is going to control the traffic that is going to or coming from the router itself. So things like OSPF hellos or EHRP hellos. Specifically, these zones are applied. Inside is on the Fast Ethernet 0/1, and outside is on the frame relay subinterface, the WAN interface. If we look at the show zone pair security, I have 2 different pairings. One is for traffic as it goes from the inside to the outside. That is saying traffic is coming from the source zone inside going to the destination zone outside. And I have the policy applied, the inside to outside policy. Then likewise, the other way around, I have an outside to inside pairing that's calling the outside to inside policy. So again, as you're defining these parameters, the more descriptive you can be in the class names, the policy names, the zone pairings, the actual zones, the easier it's going to be to read the final configuration. Now, for the inside to outside pairing, if we look at the show zone pair security, or show zone pair, not show zone pair, let's say show policy map. Show policy map, type inspect, and I want this for the zone pairing that is the inside to outside pairing. So the inside to outside pairing is a pretty straightforward policy that says I have a class that is the inside to outside class that is matching TCP, UDP, and ICMP. It says for any of these type of flows, I am simply going to inspect the traffic. So we're essentially allowing everything from the inside out that CBAC has an inspection for. Now on the reverse direction, if we look at the outside to inside pairing, which is actually, it's not called pairing, it's just called outside to inside. Okay, so the outside to inside policy is calling a couple different classes. One of them is the HTTP servers class that says I'm matching 2 different things and I have to match all of them in order for the policy to be true. Where it says not only is the traffic going to be HTTP, so it's that specific protocol, but it's also calling this access list. So now we're limiting the type of traffic that is allowed to be inspected from the outside to inside to the application, which is HTTP, but also for the particular servers. So this is how you would limit traffic that is going to your inside hosts, not only on a per address basis, but also on a per protocol basis. Then likewise, we're doing the same thing here for the DNS servers. I'm saying that I'm allowing the protocol DNS, but only if it's going to servers that are matched in that particular access list. Then the last one, I'm permitting any ICMP. This is going to be for our basic testing of the policy. Now, if we look at the result of this, if we were to go to the inside of the network, which in this case is router 4, if I were to send an ICMP ping, or if I were to send a telnet for testing our TCP traffic, we should see that there's not going to be any problems for router 4 pinging, let's say 200.0.0.1, which is router 1, or if we were to telnet to router 1. And on router 3, if we look at the show policy map type inspect zone pair sessions, so the active sessions in the state table, we do see that there's a session that was initiated from router 4 going to 1. And it's port 23, so this is our telnet traffic. So now we know the basic inside to outside policy is working. Now let's look at this in the reverse direction. If we look at the show access lists on router 3, I have 2 different lists. One is specifying the DNS servers, one is specifying the HTTP servers. In this case, they're the same address, which is an interface that is assigned to router 4. So on router 4, I'm now going to make two changes. One is to turn the web service on. So in global config, we'll say IP HTTP server. And the other is to turn the DNS service on. We'll say IP DNS server. Now for the web service, anyone who now starts a web browsing session to router 4 should get to the GUI interface for management. For the DNS server, I'm now going to put some static host entries in here so that we can actually test, is the DNS resolution actually working. So I'll say here IP host, let's say www.abc.com is an interface that's on router 4. Let's say 172.16.34.4. And the same with xyz.com. Now from router 4, if I were to ping any of these addresses, ping abc.com or ping www.xyz.com, we can see that the resolution is occurring, that it knows that this address resolves to that host name. Next, on the outside portion of the network, which we're going to use the test PC for this, I have it configured to use router 4's address as the DNS server. So if we look at the Windows command line and look at the ipconfig/all, we can see that the DNS server here is configured as router 4's address. Now, assuming that the DNS process is configured correctly on router 4, which we did already verify, and that the outside to inside policy is working on router 3, I should be able to ping abc.com or xyz.com and get those particular resolutions, which we see that we do. Now, if I were to choose any other random address, let's say EFG, router 4 is not configured with this host entry, so the DNS resolution is going to fail. But at least up to this point, it's telling us that our outside to inside policy is working. It's allowing the DNS resolution, but it's also allowing the ICMP pings. So next, let's look at the web browsing session. Let's connect to router 4. We'll say 172.16.34.4. And I'll also open another connection to 172.16.4.4. Now notice that the 4.4 session is working, but the 34.4 session is not. And the reason why is that in the outside to inside policy, when I'm matching the HTTP server class, I am calling not only the protocol, which is HTTP, but I'm also calling an access list that says it has to be specifically to this address, not to any other address. So this is now telling us that two additional things are working. Not only is the outside to inside HTTP inspection working, but it is also limiting the traffic based on the address. So now if I had an additional server that was added on the inside, the only thing I would need to do would be to go to router 3. And when we look at the access list, if I were to add an additional entry here, then that particular server's traffic would be allowed to inbound as well. Now we can additionally see that router 3 is logging traffic. It says that from the outside to the inside, we dropped a web session that was coming from, this is the Windows machine's host address, going to 34.4, because the drop action was found in the policy map. Where the drop action here, this is in the class default. So at this point, all of the inspections that router 3 is doing is based on all of the default parameters. Now, if we wanted to modify any of these to say what are the number of connections that we can have to this particular web server, or what are the timeouts, what are the maximum incomplete sessions to prevent those TCP SYN attacks, again, this would be defined under a parameter map. Now, the parameter map, we're going to look at a couple different examples of this. The first type we'll look at is an inspect parameter map that is going to be used for these different TCP, UDP, or ICMP options. And then when we get into our application inspections, we'll also look at the regular expression parameter maps that are going to be used for checking things like the HTTP URL strings or any type of string that is inside the application header that is not already predefined in a regular inspection. So next we'll define the type of parameter map, which is going to be an inspection map. We'll give it a name. I'll say that this is for the HTTP servers, and this is the HTTP servers parameters, where again, as descriptive as you can be for these type of classes, policy map, parameters maps, it's going to make it a little bit easier to piece together what the final result of the policy is. So inside the parameters, again, this is where we would change things like the individual TCP options, like the TCP maximum incomplete sessions on a per host basis. This would be, again, for the SYN attack prevention. This is the TCP intercept. TCP SYN wait time, this is saying when you're trying to open the session. So you hear the first portion of the three-way handshake, but then the server doesn't reply. How long are we going to wait? The idle time, so once the session is open, but it's not actually sending traffic, how long do we manage it? The fin wait time would be after the session is closed. How long do we maintain it in the session table? So most of these, if you were to look at the command reference, it should be fairly self-explanatory exactly what the individual options do. Now for the UDP and ICMP sessions, again, since these are not connection-oriented protocols, mainly the only thing that we could change is how long is the session going to be managed in the state table. So since there's no specific message for UDP that says I'm done with the connection, it's just going to stay in the state table until it hits this idle timeout. The same would be true of the ICMP session. A couple other options we have here would be to turn alerting on. This would be if we want to just generate a generic log message. If we were to turn the audit trail on, this is going to be a verbose log, which again is going to show us the individual connections that are occurring from the clients to the servers. Now, typically, you wouldn't normally want this one on unless there's something that you're trying to troubleshoot or some sort of attack maybe that you're trying to track down, because it is going to be a very not only processor-intensive log, but it's going to generate a lot of log messages that would be just a lot of syslog information that you would have to parse through. But for this case, I'm going to turn both of them on, the alerting on and the audit trail on. Okay, the other one that would typically be important is going to be the maximum incomplete sessions, the highs and the low parameters, or the highs and the lows on a 1 minute basis. So if I were to say that for within 1 minute, if the maximum incomplete sessions gets to let's say 4, then we're going to start to drop the additional sessions. So again, this is what's preventing the TCP SYN attacks against the web servers. Now, when we set the high threshold, it also says the low threshold is being set to 4. The 1 minute low, this would control how many sessions do we have to drop below until we stop managing the sessions. So if I were to say the 1 minute low is 2, it means that when I first breach the threshold of 4 half-open sessions, I'm going to start to run in aggressive mode, which is going to drop the new sessions. Then once I go back below 2 sessions, then we're going to stop doing the management. Okay, so if we look at our results of this, let's say show run section parameter dash map. So we have the audit trail on, the 1 minute lows and highs for the TCP sessions. Also notice that the alert option doesn't show up here. That's because the default is on. So if we did not want to log the sessions, we could turn the alert off, but alert is normally on by default. Okay, so now we have the parameter map. Next step would be to apply it to the actual inspection that we're doing. So now let's look at the show run section parameter map or class map or policy map or access list. So this is going to show us the vast majority of the policy we have configured. Now the place that I'm going to apply this is on the outside going to the inside. Because with these type of options, typically what you would be using it for would be to protect your inside web servers. Or maybe for the DNS servers, I want to control what's the DNS timeout. But here for the web servers, since they are TCP based, I'm applying the TCP normalization onto them. So this now means under the policy map type inspect, which is calling the class map type inspect HTTP server class, where HTTP server class says that it has to be not only the protocol HTTP, but this access list HTTP servers ACL, which again is calling router 4's address. After the inspect option here, this is where the parameter map is going to be called from. Where in this case, the parameter map name is HTTP server parameters. So now if we look at the show run section policy map, what we should see that has changed is now there's an inspection for these individual parameters. So next, let's actually try this out and see when we do the web browsing from the outside to the inside, does the audit actually occur and does it give us the verbose log about the session? So from the outside client, which again is this Windows host, let's open up a new session to the server, which in this case is router 4. And let's generate some traffic, let's say to show tech support. Now if we look at the result of this, on router 3 we can see the audit trail says that on the outside to the inside, specifically in the HTTP server class, this was the initiator, this was the responder, so it's router 4 on the inside. Also tells us things like how many bytes have been sent over the session. So if someone is trying to do some sort of attack on your internal servers, you could potentially use the audit log to figure out, is there one outside host that's generating tons and tons of sessions? But again, the potential problem with this is that if you have thousands or tens of thousands of sessions going on, then you probably wouldn't want the router to normally log all of these. So it could be useful to track down a very specific problem, but you probably would not want this on by default. But at least what this is showing us is that those individual parameters are properly working. So next, let's test out. We know that the audit log is working. Let's see, can we get the TCP sessions to breach these 1 minute high thresholds for the half open sessions, and see if the zone-based policy firewall actually goes into the to the aggressive mode for the TCP intercept. Now again, the way that the TCP intercept works is that when the originating client sends the SYN, which again is the first portion of the three-way handshake, the firewall is going to create the half open session. So now it knows in the state table someone is trying to connect to router 4. The firewall is then expecting the return, which is the acknowledgement and the SYN, the ACK-SYN or the SYN-ACK, which is the second portion of the three-way handshake. And then it's looking for the client to completely open the session with the final acknowledgement, which is the third portion. Now, once the first portion of the handshake is received, the firewall is then going to start counting down the SYN timeout. So if router 4 does not respond with the second portion of the handshake and the SYN timeout expires, then the session is going to be removed from the table. Now, if the first portion happens, the second portion happens, but the third portion does not happen, that's what's considered the half open session. So the SYN attack is when the client, or more specifically the attacker, is constantly pounding the server with these SYN messages, but it's never listening to the acknowledgments as they're coming back in. Now, one way that we can try to simulate this here is that when we actually receive the second portion of the handshake back in, which is going to be the ACK and SYN, I'm going to tell router 1 to filter this flow as it is going out that interface. And the way I can do this is by looking at either the ACK or the SYN. So I'll say that for any SYN packets that are going out fast Ethernet 0/0, we're simply going to drop those. So on router 1, I'm going to configure an access list. Let's say IP access list extended. This is going to drop the SYN packets. And this says deny TCP any SYN. Then we're going to permit anything else. This is then going to be applied IP access group drop SYN out. So this is going to be dropping the replies from the server. Now, from the firewall's perspective, router 3, what it is then going to see is the first portion of the handshake, which is the initial SYN. It's going to see the SYN ACK come back from router 4, but it's never going to hear the third portion because the originating host thinks that this session was dropped in the transit path. Now, what we can do is simply go back to the Windows machine and open a bunch of these sessions. So if we open our connection to the server, 172.16.4.4, and simply refresh this session over and over and over, so we'll open a bunch of different sessions. And if we look at router 3, what we should now see is that and we can see it's kind of hard to see because we have the audit trail on. And let's keep going a little bit further. Then additionally, let's look at the show policy map, type inspect, zone pair, and I want to see the outside to inside pairing, and it should show me how many half-open sessions there are. And this should be for the web sessions. So it says that the maximum ever here was 4 half-open sessions. And let's look at these individual sessions. We'll say show policy map type inspect, zone pair outside to inside sessions. Then let's try this again. Now, one thing I'm going to do just to make this a little bit clearer in the logs is to turn the audit trail off. So you can see just with the few sessions that I have going on, it's pretty confusing to try to read through the logs. So let's say audit trail is off. So let's try this again. From the the web client, if we simply refresh these sessions, we can see now the alert happens. It says for the outside to inside HTTP server class, we're getting aggressive because the current 1 minute rate is 5 half-open sessions. So now we breach the threshold of what we configured as the 4 half-open sessions, and we can see them specifically here in the output of the show policy map type inspect zone pair outside to inside sessions, where there's 4 half-open sessions. They're coming from these sources, and they're going to that particular server. Now, generally, you wouldn't have 4 as the value here. It would be some number that is larger than this, but this could be a quick way to figure out, is someone actually trying to initiate a SYN attack onto the server? Because if you see that all of the half-open sessions are coming from the same device, we would then know that this 118.100 address is probably trying to do some sort of denial of service attack. Then to fix that, we could just simply create an access list that is going to deny those individual flows. Now we could see, since we waited for an additional minute, it says now the inspection is calming down because the current count went down to 0.